what we are looking at is, I can find my note. Today, what we are looking at is finding the slope on and the equation of the tangent line. So there's some information that I want us to recall. This is stuff that hopefully we learned from way back in the day. First and foremost, this equation, you should have seen it before. Y minus y1 is equals to m times x minus x1. You remember this equation from back in the day? It is called the point slope form of a line. Y'all remember this, right? Or just not saying anything because y'all want to make everybody else feel bad.
Yes.
Okay.
Yes.
1. 2, if you have perpendicular lines, can't spell lines anymore. If you have perpendicular lines, then the slopes are opposite reciprocals. So, for example, if I tell you my first slope of my line right here is 2 over 5, then the slope of the line that's perpendicular to it would be negative opposite sign, and then the reciprocal 5 over 2. Yes?
Yes.
Again, another example, the first slope has slope negative 3, and the slope of the line that's perpendicular, i.e. a right angle, will be positive opposite sign, 1/3. That would be my new slope. Okay, so that's point 1 that I need you to remember. Point 2 that I need you to remember. And the last thing that I need you to remember is about the derivative. The derivative f prime of x is an equation for the slope of the tangent line. And of course, this one for us is the most important since, hey, the name of the section is slopes of tangent lines. Right there. Okay, so that's a little bit of a primer. It's raining outside. Questions there. Y minus y1 equals m times x minus x1 point slope form of a line. Of course, you know, there's a slope intercept form, y equals mx plus b, right? That's generally how we give our lines. And then we have perpendicular lines, opposite reciprocals. And of course, if I find the derivative, I'm finding an equation for the slope of the tangent line. So finding slopes.
Can you go back up a little bit?
Is that good enough?
Yeah, that's good. That's good.
Gotta bring the heat, people. You gotta bring the heat. Finding the slope of a tangent line. Oh, finding slopes, because you can have several tangent lines. Consider the function f of x is equals to x cubed minus 2x squared plus 2. Consider this function right here. If I was to graph this function, then the graph of the function, let's go kind of like the graph of the function, this function, I drew it on my fancy graphing machine. And it told me that the graph of the function looks something like this. If I was to pick a point of interest, say right here, at let's pick a point. Let's go to, if I was to pick a point right here too, then when I'm talking about the tangent line, I am talking about at this point right here, the line that touches the graph of the function. Let me see if I can get this thing. The tangent line, see the ruler right there? The tangent line is the line that basically goes through the function like so. When we're talking about tangent lines, this is what we're talking about. A line that goes through the function exactly once. What we are trying to do today is to simply find the slope of this line. It turns out that to find the slope of the line is actually pretty straightforward now that you know a little bit of calculus. Let me give you a second to draw that line out. So, and while I'm waiting, so do we all understand what I'm looking for? I'm trying to find the slope of this line, the quote unquote rise over run that's associated with this line right here. Oh, hold on. I'll be right back. All right, so what was that? So simple enough, I think, to find the slope of a tangent line. We simply, one, find the derivative, and then two, plug in the value of x. And so in my example right here, my function is f of x is equals to x cubed minus 2x squared plus 2. And so if I wanted to find the slope, I will first find the derivative, like what we did today on the test. It's going to be 3x squared minus 4x, like so. And then if I want to find the slope of the tangent line, is simply f of 2, sorry, f prime of 2, which is going to be 3 times 2 squared minus 4 times 2. 2 squared is 4,
Could you re-explain that, please?
Which part is the explain? Which part?
So f of x equals x cubed minus 2x squared plus 2, everything under that.
All right, so see right here, the little prime right here? That means I'm taking the derivative. And so we do what we did before. Remember there's a 1 right here? So 1 times 3 is 3, and then you subtract 1 from the power to get the 2. And same thing, the squared, 2 times 2 is 4. Well, 2 times negative 2 is negative 4. And of course, the derivative of a constant is 0, so that cancels out. Okay?
Yep, thank you.
And then you just plug it in, plug in 2. When you plug it in 2, you got an answer of 4. And that's all you have to do to find the slope of the tangent line. So literally, if I go up here to this tangent line up here, the slope is going to be 4. The rise over run for that line right here is going to be 4.
How'd you know how to plug in 2?
Because the x coordinate of the point I'm looking for was 2.
Okay.
Anybody else? And so if I switch over to, I am looking for, why is it not breaking? I don't have it on here. I don't want the graphing calculator. Oh man, I thought I put this on here already. Think clearly, think carefully. Think looking for. Oh, didn't I download it yesterday? Oh boy. APP. This thing is confusing. I have to. I had it yesterday. Oh, it is on the phone. Oh, okay. I thought I had it yesterday. What happened? Right. And so if I take my function was y is equals to x cubed raised to x cubed. It was minus 2x squared. I'm asking you, I should know, right?
Yes, minus 2x squared.
Sure. Squared, and then plus 2.
Yes.
Thank you very much. Let's do right here, and that's the graph of my function right here. And so what they're saying right here is that if I look at this graph of this function right here, and I add in this line right here, the line y is equal, oh, it's not working. The slope of the tangent line. Oh, I don't know the equation of tangent line. We're going to find that next. But if I was, can I draw this thing? No, it's not good. I can do this. Y equals 4. So if I go with y equals 4x right here, this line right here, can I move it? No. This is going to be parallel to the slope of the tangent line, but it's not allowing me to move it. Anyways, I digress. I'll come back to this in a second. So it'll be all fancy and everything. So my question to you is, now that you know the slope right here is 4, can you find the slope at 1? Right here, find the slope of the tangent line at 1, find the slope of the tangent line at 0, and find the slope of the tangent line at -1. So for me, please, for the same equation, find put the answers in a chat message for me, please. Find the slope of the tangent line at x equaling -1, x equaling 0, and x equaling 1. So that's 3 slopes. Find those 3 slopes for me, please. And everyone's seen the answers already, so let's just go ahead and find them. So f prime at -1 is going to be 3 times -1 squared minus 4 times -1. So that's going to be 3 times 1 plus 4. So that's going to be 7. F prime of 0 is 3 times 0 squared minus 4 times 0, which is 0. Right, so that slope of that tangent line is 0. And then the last one, f prime at 1, is 3 times 1 squared minus 4 times 1. That's 3 minus 4. Gives me an answer of -1. Questions there on the slopes of those tangent lines? Interestingly enough, when you have a slope of a slope is 0, that means the line is horizontal. And so if I go back up here and I look right here, see my tangent line at 0 right here, this tangent line right here, that's the tangent line that's horizontal, that's going left and right. This one right here, the slope is -1, and so the line is sloping downwards as I read from left to right. And of course, this one should have the highest slope. Obviously, my line's a little bit off. Goes this way right here. This one here has slope equaling 7. Questions there on finding the slope? Okay. So then that takes us to finding the equation of the tangent line. So find the equation of the tangent line. Well, it turns out that finding the equation of the tangent line is not that difficult already because we've actually done most of the hard work. So find the equation of the tangent line at the same point, x is equal to 2. So that's the question right here I'm trying to solve. And so I'm trying to find the equation of a line. And so therefore I have to use this right here, y minus y1 is equals to m times x minus x1. That's the formula for the equation of a line in point slope form. The equation of a line in point slope form requires 3 pieces of information. It requires, first, the slope of the line. Second, it requires a point which the line goes through. That's your second piece, and that's your third piece of data. Okay? Y minus y1 is equal to m times x minus x1. First thing it requires m. It turns out we already know what m is, because m is simply the slope of the tangent line, which is what we did before. Again, I'll just rework it. But we know the answer is going to be 4. That's 4, that's 12 minus 8. And so I know the slope is 4. Question is then, how do I find the point? Well, to find the point, we go back to the graph of the function. If I go back to the graph of the function, right here, I am trying to find the equation of this green tangent line right here. This is the only point that the graph goes through. And so I automatically know that the x coordinate is 2, but I do not know what the y coordinate is. I know the x coordinate is 2 because I am at x equals 2. Questions there? So if I know x is equals to 2, how do I find the y value? It turns out that if I know x is equals to 2, I simply use the equation of the function to find the y coordinate. Simply plug in 2 into the function. And that will work towards giving me my y coordinate. That's going to be 2 cubed minus 2 times 2 squared plus 2. 8 minus 8 plus 2. And so the y coordinate is going to be 2. Questions there?
So never mind. I get it.
And so we have compiled 3 pieces of information. M is equals to 2, and the point that the graph goes to right here is x is 2. M is 4. My goodness. I mean, all these 2's mixed up. M is 4, and the point that the graph goes through is 2, 2. With this right here, I can then plug all 3 of these in here and simplify, and that will give me the equation of the line.
Okay, so like with the points, you just can't get the points from the graph?
Technically I did, but I got them from this part of the graph, the equation itself. Is that what you meant? I took the 2 and I plugged it in here. What do you mean? Can I just read it?
Yeah, can you go back down?
Mm-hmm.
Okay, so why is it gonna be 2, 2? I know where the 1, 2 comes from, but where does the other one
So
come from?
this is x, y. X is equals to 2, right? So that's how I got x equals 2 right here. If I have a table of values and I tell you that x is 2, how do I find the y value? I have to take the 2 and I have to plug it into the function and work it out. And that gives me my y value. Yes or no, maybe so.
Yeah, I understand now.
And so I use these 3 things, I plug them into my equation. Y minus y1 is equals to m times x minus x1. So y minus 2 is equals to 4 times x minus 2. Y minus 2 is equals to 4x minus 8 after I distribute the 4. And then I add 2 to both sides. Y is equals to 4x minus 6. This is the equation of the tangent line. Questions there? Comments? Queries? Concerns? Okay,
Can we do another example?
sure. But before we do another example, if I go back over here and then I fix this equation. Now that I know the equation of the tangent line, I can put it in. It is y is equals to, I believe it was 4x minus 6. 4
Yeah.
minus 6 right here. You see right here, that new line just showed up right there. That new line that just showed up right here, that new line is the tangent line. What's it doing? What's it doing? All right, and so you see this line right here, that's a tangent line, right? So this line has a slope of 4, and it goes through the graph exactly at that 1 point. See this point right here in gray, see it's the coordinates of that point is 2, 2. That's exactly the tangent line that goes to that point right there. If I was to trace this tangent line back, you'll see the y-intercept for this graph right now here is -6, which is the 4x minus 6. You can find any tangent line for this graph right here using this method that we just did. Questions there? So, for example, if I wanted to find the tangent line at -1, -1 is right here. That's right here. If I want to find the tangent line at that point, -1, we would have to basically follow through the same steps. So, another example, find the tangent line of f of x. I'm going to use the same equation. X cubed minus 2x plus 2 at x equaling -1. Step 1 is find the slope. So I just take the derivative, which we already know was 3x minus 4, 3x squared minus, oh, that should be 2x squared. 3x squared minus 4x. And then, what number do I plug in here for x?
Is it -1?
-1. That's going to be 3 times -1 squared minus 4 times -1. We already did this. The answer was 7, right? What is going on back there? And so I have the slope. Step number 2. I know that x is going to be -1 because that's where I'm trying to find my equation at. And then step number 3, I have to find the y value. That's going to take the function and plug -1 into the function. Whew. -1 cubed minus 2 times -1 plus 2. That's -1. Yes, -1 times -1 plus 2 plus 2 will give me an answer of 3. Is that right? Plug in -1. Yeah, that's right. Have I lost anybody? So the slope is 7 and the point is -1, 3. I plug all of that into the equation, y minus y1. Y minus y1 is equals to m times x minus x1. Y minus 3 is equals to 7 times x minus -1. Questions there if I finish this off? Okay. So y minus 3 is equals to 7 times x plus 1, a negative and a negative. Y minus 3 is equals to 7x plus 7. And then you have to add 3 to both sides. Y is equals to 7x plus 10. Questions there? So that means that if I try this out, if I did this correctly, which I am not sure I did, I'm plugging -1, same answer is -1. How? Oh, I found my mistake. Oh man, I'm missing the square sign right here, people. Oh man, it was right. So that's going to be -2. And so the answer is -3 plus 2. The answer is going to be -1. And so therefore the point is going to be -1. Okay. So that's going to be y minus -1. So that's going to be y plus 1. And then it's going to be y plus 1. So I subtract 1 from both sides. So y is equal to -x plus 6. Questions there? So now I go back over here and I put in the line y is equals to 7x plus 6. Hopefully, the line right here will go through exactly at this point right here. At that point right here, the two lines meet. The tangent line and the curve, they meet exactly at that one point right here. That's where they intersect at -1, -1. Hence, we know we have found the correct equation for the tangent line. Questions there? Comments? Now, it turns out, do I have enough time? I have enough time. Now, it turns out that in addition to the tangent line, we are also in need of another line called the line normal to the tangent line. The line normal to the tangent line is the line that moves at a 90-degree angle to the tangent line. It goes this way. In physics, finding this line is very important. We call this line the normal line. It moves at a right angle to the tangent line right here. It turns out that finding the line normal to the tangent line is pretty straightforward. But seeing as I only have 5 minutes, I think I'll leave it for the next time. And so instead, let me ask any questions on finding the equation of the tangent line. Step 1, find the slope. Step 2, identify the x value, where you're finding the tangent line at. Step 3, find the y value. And then the last step is to plug them into the equation and work it out. Any questions there? All right, then. You all have a nice day. Bye-bye.